Alright, here's the 10 coiler. Now, a couple of remarks. I just really haven't done much with it. I just got it running here and looked it over. Had to just slightly move one coil. About that, they're placed in quite an odd configuration. The primary coil at the bottom, which is correctly positioned, is all the way to the bottom, so that's really kind of interesting the way they had it here. They have it set for about 2 amps input, and really you'd want to be pushing this more, but the resistors are set as John had his, which was a totally different system anyway. 220 ohm resistors on each board, each base of the transistor, and then 470 down at the bottom, each branch resistor 470. So it's really well, it's more very negative in the sense of there's not going to be any current in this arrangement. So it does charge batteries. We'll see that in a minute. I'm going to bring everything around here, but I just want to mention some of those details. So this is with a 23 gauge wire. This is not the 18 gauge wire, so this is basically they're doubled up though in this case, so that's like it's 18 almost. So I think this is what he did when he contacted John, and John said to do this to him, I guess. The 20 coiler was done a little bit better, but it's the same kind of situation here. So it's kind of neat. It's a little dusty, needs to be just cleaned off. I blew it off with the air compressor, so it's alright. And what else was I going to say? The wires are something to be desired, not to be desired, but whatever, they work. And what else was I going to say? Yeah, so you can play around with the gaps. This is meant to be run at a higher voltage, really. But anything above 24 volts, the neon bulbs are just going to come on automatically, if you don't know that already. So let's just get it to start, and starts right up. I didn't have to do anything. There was one solder joint that I had to do, which was kind of loose there, and I just fixed it. So you have all these switches here to turn on off all the coils here. Each one's numbered to each coil around here. And so let's turn on the amp meter so you can see. Alright, so I'm just going to hook this up like I always do with a clip rather than hardwire it, because you never know. I don't have any fuse on it. So alright, so we're at 1240. It did charge up a little bit with these batteries. It was at 1235. I just ran it for 5 minutes to make sure everything was good. So you can see all the details. And this wire obviously is not going anywhere, it's just for clamping purposes. And so what I'm saying is you can see the gaps here. They're pretty close on this side, and then on the bottom, like you can see really far, and there's more of a gap. So it's just kind of an interesting thing. So the big huge load on this case is this LED. The LEDs. And these are the little feet here that tend to come off if you move it around. Alright, so we're going to start this up. So you can see the amperage, see the voltage. So this will just purr like a kitten. You could put some of that lube in there. Maybe, I don't know if anything was ever put in there, but so you can see that it's up to 2 amps, and then it's just going to climb. I mean, this really needs to be at 24 volts, of course, but we just wanted to get it running. I would do a thorough look over of everything, and so you can hear it kind of buzzing a bit. Once it gets up to speed, it will then go like that. So there's a sweet spot. So the other thing is, I don't know if he glued in the rods, but I always put glue on the top of them. I never assembled these back when he bought it. This is one of the first ones. There's actually a serial number right here, well, somewhere on there, but so anyway, you can just put some crazy glue into the rods, and that will be good. So you can see now, right now, it's actually up to 3 amps, and then it will probably come back down here. But you can change out these resistors, like I said, right here. These are the branch resistors. I usually run this more, at least at 100 ohms per base resistor, but this is the way John wanted to do it, I suppose, when he talked to the customer. I'm not going to say who it is, but he is a known person in this research. So it looks like all the transistors seem to be fine. I don't see any problem with anything here. So now we can, this is turned up all the way here. I'm not sure what that rheostat value is. 1.5K actually, yeah. So that's a little high for this, but I guess it's not for what he's doing. So of course I've got this on the negative. It's going to be the same. So now if I go down, maybe we can see, still picking up some speed. So now I just turned it and it's going to speed up. So you can see it is charging. So maybe 3 amps here. So it's just a little bit of dusting and that, and it should be okay for presenting. So I guess, I mean, this is really what you're going to get for 12 volts, unless you lower the resistance and also push the what do you call it? Push the prime or the master coil up. And yeah, I would replace these lines with thick, short wire rather than funky wire that they have here. Other than that, I think it'll be a great little, well, not really little, great machine. So again, we could turn down, see if this goes up higher. Pretty much it. just turn it off. Of course, it's got no amperage anymore, but you can see the voltage is going to hold more or less. It'll come down a little bit, but oh, you can see, interesting, the lights, the neon lights coming on with this on the primary coil because of the arrangement. Actually, you can see it on here too. So there is some magnetic generator action going on, even as it is. So this is what you have to really be careful of, that you don't damage your parts. And leave the charging battery connected while it's spinning down is what I'm getting at. So you can see yeah, I mean, I should probably sell this for a lot more, but whatever. Alright, so I think that's good.